Very good morning, everyone. And the examination, the GATE Electronics and Communication examination is closer. Okay, just on 15th of February, that is after 3 days. Okay, Saturday, you have the EC exam. And signals and systems is a crucial subject, we know. Okay, and which also has the potential of producing good questions. Okay, so yes, dear, one rapid fire revision through 21 important questions covering important areas and important models of the question from signal and systems will be taken in this class. Saturday, you have the EC exam, and All right. Okay, very good morning, Asif. Very good morning, Anay Reddy. Good morning, Mahesh. Good morning, Hovant. Okay. Good morning, Kishore Kumar. Okay. Yes, so time to get started. Students are joining. They'll keep joining. Quickly update all your friends that the session is now live so that they join quickly. Good morning, Likith. Okay, fine. All right. Okay, so guys, let's get started, with the 21 important question sessions on the signal and system. Okay, it's going to be a rapid fire revision also for the important topics of the subject. And yes, guys, the GATE 2026 or 27, the online live course just started, a fresh batch just started 8th February. And yes, you can enroll into it. The fee for 1 year validity, that is for GATE 26, is 19,999 currently, and for 2 years it is 28,999. All right, very good morning, Ajay Kumar. And yes, guys, if you want to directly come to Hyderabad and take the beauty study with the offline batch, the first regular offline batch for GATE 26 starts 24th of February. The fee currently is priced at 54,999, wherein you can, study in a competitive atmosphere among hundreds of students and at the same time take the direct, one-on-one guidance with the faculty in front of you at the Hyderabad Center. Okay, guys, now the first question. Let's get started. Let's get moving ahead with our question series quickly. Good morning, Sairaj. Okay, so the first question. Okay, what is the value for integral 0 to infinity t square delta 2t minus 3 dt? Okay, integral 0 to infinity t square delta 2t minus 3 dt. Okay, so now it's integration of with respect to impulse signal, and we know that in this case, first of all, I would notice the location of impulse and see whether it is within the limits. Otherwise, if the impulse is outside the limit, then the answer is 0. So very clearly, the impulse is located at 2t minus 3, the argument equal to 0, t equal to 3 by 2, which is within the limits, right? Which is within the limits. Okay, now it's a scaled impulse signal. Okay, time scaling has been applied to this impulse signal. Okay, Prashant has some answer, 9 by 8. See, remember, time scaling has been applied to it. Okay, and there are two ways to deal with this. Okay, you substitute 2t minus 3 equal to some parameter p. Okay, or how can you represent delta? How can you represent this value delta 2t minus 3? Delta 2t minus 3. So we know that it is an impulse at 3 by 2. Okay, so it should also be represented in this form, delta t minus 3 by 2. But if I say delta t minus 3 by 2, it will have unit area. Now delta 2t, what is the scaling effect of impulse? Okay, when you scale it, 2t means you're compressing, so area will also be compressed and the area effectively becomes 1 by 2. Okay, if I separately write down the impulse scaling property, delta at, it can be represented as 1 by mod a delta t. 1 by mod a delta t, right? So if you put it this way, then the question will look like integral 0 to infinity t square into 1 by 2 delta t minus 3 by 2 dt. And then what is the property you are going to use? What is the property you are going to use? Integral of any signal xt, okay, into delta t minus t naught dt is equal to x of t naught. is equal to x of t naught. Only thing is the location of impulse. What is the location of impulse? T naught should be within the limits. Okay. Okay, this t naught should be within the limits. Otherwise, answer is 0. Within the limits. Limits of what? Limits of integration. Otherwise, the answer would be 0. Otherwise, the answer would be 0. Otherwise, the answer is 0. Okay, so this is equal to 1 by 2. Okay, t square. Now, what is t? 3 by 2. So, it becomes 3 by 2 square. The value of the signal at t naught. Okay, what is the function t square at the value 3 by 2? Okay, so it becomes 3 square 9 and then total 2 cube 9 by 8. Very correct answer. It's a NAT question. So, that means I can write it as 1 by 8, 1.125. 1.125. Correct? Yes, Prashant, correct answer. 9 by 8 or 1.125 is the final correct answer to this, right, dear? 1.125. Moving ahead to the next case. We'll be moving ahead to the next case. Which one of the following is a periodic signal? Which one of the following is a periodic signal? It's a MCQ question only. Okay, I have taken some MSQs also in the session. So wherever MSQ is there, I'll let you know. Which one of the following is a periodic signal? Okay, so see, first of all, if a signal multiplied by ut, okay, see, if I remove the ut, then any signal, any complex exponential signal which has pure imaginary power, a e power j omega t, is always periodic. Okay, right? If you talk about a e power j omega t, if you only talk about this one, this is definitely periodic with the period 2 pi by omega. This part is periodic, but okay, e power j into t plus pi by 4. Pi by 4 is some constant phase, doesn't matter. But if the ut was not there, signal would have been periodic. But now ut means the signal is only right-sided. And when I say periodicity, dear, when I say periodicity, means the signal should be periodic from minus infinity to infinity. That is the standard way of checking the periodicity. So this ut is going to make this signal as aperiodic, because the signal is only right-sided, one-sided. We don't call it as a pure periodic signal. Okay. Then similarly, if you come here, e power minus of 1 plus j into t, so it is e power minus t, if you open the bracket, e power minus t, e power jt. This part is periodic, but this part is aperiodic. Okay, so the overall answer is again aperiodic. Okay, e power minus t, it's an exponentially decaying waveform. It does not have any periodicity. It's an exponentially decaying waveform, right? Okay, so now Prashant says answer C, Harsh says answer C. Okay, now coming to B, dt, un plus u minus n. It is dt, be careful. Okay, so because it is dt, what is the waveform corresponding to it? Now I'll just show you the waveform. Then you can look and decide. Okay, then you can look and decide. X to n. See, if you want to talk about the waveform, un, first take un. Un takes the value 1 from origin. Let me only draw un. And it goes to infinity. U minus n, mirror image of this. But when you take the mirror image, what happens to the sample of origin? It remains at origin, and then you are adding it, superimposing it. So value at the origin actually will be more. The value at the origin will be 2, but yeah, whatever is the value at 1 will go to minus 1. So all these values on the left will be 1. It comes from minus infinity. If this was also 1, I could have called it as periodic signal. Okay, if this was also 1, I could have called it as periodic signal. The value 1 repeats after every 1 unit of time. But okay, the value at the origin is doubled, and that loses the periodicity pattern. So this is again aperiodic. This is again aperiodic. The only option number C is left. I'll explain you how, but yeah, only option number C is left, and that should be periodic. That should be my answer. That is clear, na? That should be my answer. Now, what is there in the x3n? Let me sketch it separately. What is this x3n? If I write down here separately, x3n is given by summation minus infinite to infinite delta n minus 4k, na? Yeah, delta n minus 4k, and then minus of delta n minus 1 minus 4k. How this waveform is going to look like? See, if you expand, if you open this waveform for different values of k, if you open it for different values of k, let me do that. Okay. Suppose dear k equal to 0. K can be any value from minus infinity to infinity. K equal to 0. So delta n minus delta n minus 1. Delta n minus delta n minus 1. Okay. So what is delta n? It is the impulse at origin. That's the impulse at origin. Minus delta n minus 1. Impulse at n equal to 1 and negative impulse minus delta n minus 1. Okay. Now, if you put k equal to 1 then directly. If you put k equal to 1. Okay. So k equal to 1 delta n minus 4. Delta n minus 4. Very good. Delta n minus 4 will be an impulse directly at 4. Okay. And then delta n minus 1 minus 4. Delta n minus 5. So impulse at n equal to 5. Okay. Then n equal to 2. So delta k equal to 2. So delta n minus 8. There is an impulse at 8. And then there is another negative impulse at 9. Etc. So there is a repetition pattern. If you take k negative also it will work. If you take k negative, okay, so delta n plus 4, there will be an impulse at 4. Delta n plus 4, there is an impulse at minus 4 and delta n minus 1 plus 4, so delta n minus 1 and plus 4. So delta n plus 3, so there is an impulse at minus 3, negative going impulse. Okay, so this pair of impulse 1 minus 1, 1 minus 1 repeats. Okay, repeats after every fixed interval of time. After every fixed interval of time. Okay, so this signal is periodic. This signal is periodic. Having how much of the period? If I ask you the time period. Okay, so let me measure it from this origin impulse, and the next impulse is at 4, and I can call it as the fundamental period. The fundamental period is 4. The fundamental period of the signal is equal to the 4. Clear? The fundamental period is equal to the 4. Correct answer? Yes. Yes, Harsh, correct. If it was un plus u minus n minus 1 will be periodic, because u minus n minus 1, okay, u minus n minus 1 will be starting only from minus 1. Okay, so entirely from minus 1 infinity to infinity you'll have constant 1. That can be periodic. The value 1 repeats after every 1 unit of time. Okay, fine. That is the correct answer. So x3n is periodic with the period n equal to 4. With the period of n equal to 4. Now let's go to the next question. Okay, let's go to the next question. Number 3. A signal xt equal to xct plus xot, where xct and xot represents the even and odd components. Even and odd components respectively has a total energy of E. If E represents energy of even part and EO represents the energy of odd part of the signal, choose the correct option. Now what is the formula for even part? Okay, what is the formula for even part? See, what is given that there is a signal xt, which has some total energy of E. It has some total energy of E. So what is the formula for even part? xt plus x minus t divided by 2. xt plus x minus t divided by 2. And what is the formula for odd part? xot. It will have xt minus x minus t divided by 2. Okay, xt plus x minus t whole divided by 2. Okay. Now, choose the correct option. E naught by E equal to 1. The ratio E naught by EE or EE by E naught. Whether it is equal to 1, greater than 1, or what is greater than 1? EE upon E naught or E naught upon EE. Okay. Yeah. Let's think about this. Let's think about this. Now, we don't know whether the xt or x minus t can be overlapping or non-overlapping. If they are non-overlapping, then the story will be different. But if they are overlapping, the story will be slightly different. Okay. Right? Have a look into this. Have a look into it. Okay. So see dear, what generally can I say? What is the energy for EE? Okay. What is the energy for the even part of the signal? What is the energy for the even part of the signal? It is equal to, now, energy of x and energy of x minus t will be same. There is no effect of time folding on the energy of the signal. Okay, so what is the energy of xt? It is E. Okay, divide by 2. Okay, amplitude scaling, 1 by 2 square. Energy is proportional to amplitude square. So 1 by 2 square, then energy of the xt. What is the energy of the xt? E. energy of the x minus t is also E, and if xt and x minus t have some overlapping, then how do you calculate energy? Energy is the area under the square. Okay, so when you take integration of xc square, it becomes a square plus b square plus 2ab. A square plus b square plus 2ab. So there is another term twice. Okay, integral of xt x minus t. Xt x minus t. Xt x minus t dt. Okay. Right. So yeah, if non-overlapping, then energies may be same, but yeah, generally we have to consider. So see, xt x minus t dt, that is one case. And what about E naught? E naught, again, amplitude scaling factor 1 by 2 square. Now, a minus b square, a square plus b square still will be there. That is integral x square plus integral x of minus t square. Doesn't matter, both have the same energy, EE, minus twice minus 2ab. Okay. So if there is some area under xt x minus t, here it is going to be added, here it is going to be subtracted. Here it is going to be first case added, second case it is going to be subtracted. Okay, so what can I say when I compare these two expressions? The comparison says that the EE is greater than E naught, and if there is no area, it may be equal also. Okay, equal also. It may be equal also. Correct. If xt x minus t were non-overlapping, if the value of this integral turns out to be 0, then both will have e plus e. Okay, whole divided by 4. Then it will be same also. So what is the correct answer? Correct answer is option number D. EE divided by E naught greater than equal to 1. Okay, I'll explain you by one more simple example. If this is okay, this is clear. I'll take one more simple example. Let's take an example here better. Let's take an example here better. Okay, so suppose if this is the signal you are talking about. Suppose if this is the signal xt you are talking about, let me consider overlapping in general. Okay, this is minus 1, this is 3. It is neither even symmetric purely. Okay, but yeah, when you draw the even symmetric part, how the even symmetric part will look like. Okay, to draw the even symmetric part, what I will do for your convenience, first I will draw the x minus t and understand this way. If I draw the x minus t, it will be from minus 3 to plus 1, mirror image. Minus 3 to plus 1, having the same amplitude. Let's take the amplitude as 2 here. Amplitude as 2. Okay, now what is the even part waveform? What is going to be the waveform for even part? What is xct? Xct we know is xt plus x minus t divide by 2. So when you add, okay, the waveform will start from minus 3 to minus 1. The value of the addition will be 2 plus 0. Then between minus 1 to 1 both are common. The value will raise, and from 1 to 3, okay, again the value will be 2, or then whole divide by 2. So this is 1 to 1. This is the waveform for even symmetric part. Okay. This is the waveform for even symmetric part. Next, what should be the waveform for odd symmetric part? Okay, so xt minus x minus t. So when you subtract, first part is 0 minus 2, negative. Okay, so 0 minus 2 and then divide by 2. So this is going to be minus 1. Between minus 1 and 1, both are having the same value. So 2 minus 2, 0. And then from 1 to 3, this is 2 and this is 0. So 2 minus 0 is 2, and then whole divide by 2 will give you 1. Now very clearly, see, energy of, amplitude folding has no effect on energy, because energy is area under the square. So if you take square, it will become plus 1. Okay, so, there will be these two parts. Okay, common here also. Okay, but between minus 1 to 1, it has the amplitude 2, it has the amplitude 0. So this is definitely having more energy. Okay, this is definitely having more energy because of overlapping. I told you, if overlapping is not there, then energy will be equal also. Okay, so that is why generally EE upon E naught is greater than or equal to 1. That also you have to be careful, whether only greater than 1 or greater than equal to 1. D answer. Okay, I hope these two waveforms are very clear. Okay, which will have more energy? Okay, the even part can have the more energy as compared to odd parts. If there was no overlapping, then both will have the same energy. Right, dear? Okay. So either the formula analysis or some random example you can take. What is meant by non-overlapping, dear? If suppose the signal xt was only towards right, only on the right side of the plane. Okay, suppose it was from 1 to 3. So when you take the mirror image, it is totally on the left side. There is no overlapping. So there will be no addition part and there will be no subtraction part. Okay, so then energy will be same. Then energy will be same. Yeah, it's a good question. It's a good question to check your concepts. Okay, it's a good question to check your concepts. Okay, the answer D has to be the correct one. Next question, dear. Next question, dear. Number 4. If the input-output relation, okay, simple one, type of expected question. Integral minus infinity to 2t, integral minus infinity to 2t x tau d tau, then the system is what? If the input-output relationship is given to you, integral minus infinity to 2t x tau d tau, then the system is what? Whether it is linear or non-linear or time invariant, time variant, causal, non-causal, stable, unstable, using properties, several options are formed. MCQ only, one of the option is correct. What is that option? Integration. Integration, so we should know it's a linear operator. We need not check. Okay, so it is linear. Okay, because of integral being a linear operator, we know that it will always follow additivity and scaling. Integral is a linear operator, so it is linear. Okay, then is it causal? Let's check out the simple things. Is it causal? Okay, if you have solved standard questions or if you have followed any of my classes, I have told you already. See, I've told you already that if it is integral minus infinity to t, okay, about time invariance difference will come. If it is minus infinity to t, it is going to be causal, but here it is minus infinity to 2t. Okay, 2t, you are calculating the output at t and the value of the input required is up to 2t. Area under the input up to 2t, that means future. Future will be there. Okay, future can be there. Okay, so definitely non-causal. Okay, it is non-causal. Okay, it is non-causal. Okay, stability. Okay, suppose if you take xt equal to 1 for all t. Example. Okay, that means bounded input. I have taken an always bounded input. The input is constant. For simplicity, I assumed constant, not necessarily constant, but okay, for simplicity, I assumed it to be constant. Then what is the answer of the integral? Integral minus infinity to 2t x tau, but x tau is always 1. What is integral d tau is tau minus infinity to 2t, and that becomes 2t minus plus infinity. It's unbounded output. It will grow with time, and as well as because of the lower limit, directly it is unbounded. A bounded input giving you unbounded output, it is unstable. Okay, unstable. Okay, unstable. Now coming to the important point, time invariance, which is there. Okay, time invariance. Okay, whether it is time invariant or variant. Yes, correct answer B. Okay, B is the correct answer. Now, whether it is time invariant or variant, see, it is non-causal, it is unstable and linear. Okay, B answer is correct. Let me explain you about time invariance also. Okay, if it is, first let me write down. If it is, the time invariance is because of the scaling factor, I'll explain you how also. Integral minus infinity to t, if this was the question, then it will be time invariant. Okay, but if the question, like the current one, integral minus infinity to at, whether the limit is 2t, 3t or t by 2 or anything, then that is going to be time variant. That is going to be time variant. Okay, so here my answer is B only. It is linear, non-causal and unstable. Okay, that is what matches. Okay, it is time invariant. It is time variant because of at. Why? I'll explain you now. I'll just explain you for this example. See there. Okay, what is given to me is integral minus infinity to 2t x tau d tau. Okay, what do we do? Okay, first, okay, try a delayed input. Okay, you take a delayed input. Take a delayed input. Suppose the delayed input is x1t given by x of t minus t naught. You delay the input by some amount t naught. Okay, so what is the output? Suppose y1t. The output is given by integral of the input. Integral minus infinity to 2t. Which input? x1 tau. x1 tau d tau. Okay, now I can write this as integral minus infinity to 2t x1 tau. What is x1 tau? Okay, t replace, you have to make a tau function. So here also you will replace tau, t by tau. So x of tau minus t naught d tau. This is the output obtained by delaying the input. Okay, but what I want, what is time invariance property? What is the time invariance concept? That a time shift in the input should produce a similar time shift in the output. a time shift in the input should produce a similar time shift in the output. Should produce a similar time shift in the output. Okay, fine. Okay, so now let's try, okay, y to t. Let's try to form the output y to t, which is y of t minus t naught, because if the input is xt minus t naught, it should produce the output yt minus t naught. So I am separately calculating yt minus t naught, and this output produced by the delayed input should match with the same delayed output. Okay, so what is yt minus t naught? Integral minus infinity to 2. Now see, when you change t, here right side t is in the form of limits. Okay, so here it is going to be changed. Okay, x tau d tau. X tau d tau. Okay, now both integrals should look like same if you want to compare. No problem. Replace tau minus t naught. Okay, you can replace tau minus t naught by some variable p. Okay, then it becomes integral xp dp. Okay, if tau minus t naught is p, d tau will be dp only. T naught is just a constant shift. Limit minus infinity minus t naught will be minus infinity. Upper limit will change. Okay, tau is 2t, so p limit will be 2t minus t naught. Now see, both are now having the same integrand function, integral xp dp or integral x tau d tau, right? Now you see here the difference is limit twice of t minus t naught, that is 2t minus t naught separately, y1 not equal to y2. Okay, y1 not equal to y2. Oh, I hope you remember, this is the standard procedure of checking the time invariance. A time shift in the input should give the similar time shift in the output. So if y1 equal to y2, then the system would be time invariant. Done. Okay, so it is not time invariant. That's what I have just put the point here, and the correct answer is option number B. The correct answer is what? The correct answer is option number B. Right. Next question. Number 5. Okay. If the signal xt shown in the figure A is fed to an LTI system having impulse response ht as shown in the figure B, what is the value of the DC component present in the output yt? What is the value of the DC component present in the output yt? Now see here. These are all aperiodic signals. Now, first of all, what is the output yt? Okay. This is a signal xt is fed to a LTI system having an impulse response. Okay, output. How do you calculate output of any LTI system? The output is calculated as the input convolution with the impulse response. Xt convolution with the ht. Correct. Xt convolution with the ht. That is what I will do. Perfect. Xt convolution with ht to be done. Now, this means that. What does it mean? Let's check. What does it mean? Let's check it out. Okay, xt convolution ht. Now, what is the value of the DC component? Okay, now this yt will have some frequency information, okay, to be represented by the Fourier transform y omega. Okay, yt will have some Fourier transform y omega. What I am looking for? Okay, the DC component in the output. The DC component corresponds to omega equal to 0. That is y0. Okay, the frequency, the DC information, DC component y0. Now, y0 as per the basic Fourier transform property, y0 is also given by integral minus infinity to infinity yt dt. That is the area under the signal. Okay, and the signal yt is obtained as convolution of xt and ht. Convolution of xt and ht. Okay, so integral minus infinity to infinity yt dt means what? Okay, area under yt, and yt is the convolution. Yt is the convolution, so that means the area under yt should be equal to area under xt. Whenever two signals are convoluted, the areas can be multiplied to find the final output area. Okay, so area under xt and ht, can we calculate this? Why not? Xt is a triangular pulse, half into base. Base is how much? 2 units. Height is also 2 units. That is the area under xt. Area under ht is the rectangular pulse. Okay, base into height. Base is 2 unit, height is 1 unit. So total answer, this is 2 cancel. 2 into 2, 4. Answer should be 4. Yes, Harsh, correct answer 4. Prashant, just recheck the calculation once. Yeah, aspirant, the exam was easy, but still 67, 68, I think you should be, safely under 150 rank or so. Okay. Safely, I mean on the safer side also if I say. because normally if it's a difficult paper, 67, 68 is usually the topper's trend. For moderate paper also 67, 68 usually, you know, can fetch you rank under 100 or under 60, under 70, 75. But this year paper, yeah, 150 I think can be a safe score, can be a good safe rank for you below 150. Right, aspirant? Okay, dear. Next question, dear. This is done. Okay, ready for the next question? Yes, Avinash, correct answer 4. Next. Here it is. Have a look into the next question. So what is here? For a time invariant system, the different combinations of input and corresponding output. Pure concept question it is. Pure concept question. It's a pure concept question. For a time invariant system, say they don't say linear, but they only say time invariant system. Different combinations of input and corresponding output are given below. You have to find the impulse response of the system. Now, what is impulse response? What is the meaning of impulse response, HN? Impulse response of the system is the response or is the output of the system to unit impulse input. To a unit impulse input. Okay. Now, dear, important point is there is no options here, I think here, no problem. See, now look into this X3n. This is purely a type of impulse input. Okay, but a scaled version of the impulse input, because if I ask you impulse input at origin will take the value 1. Okay, so the X3n, dear, listen to me carefully. The X3n can be written as 3 del n. Isn't it? Only it has one non-zero sample and that is at origin, but the value is 3 del n. Okay. Now, if the input is 3 del n, can I say, see, what is the impulse response Hn? What is the impulse response Hn? Impulse response Hn means when the input is equal to del n, the output of the system is named as Hn. Okay. So here, if the input is X3n, can I say that the output Y3n for 3 del n is equal to 3Hn? That means, can I say that this output is 3Hn? So divide by 3 will give you Hn. Listen to me. Can I say that this is 3Hn? I could have said it. If the system was linear. The system is only mentioned as a time invariant system. Okay, this is the scaling property. What I have applied? Scaling property. Scaling property is only for linear. Linear systems has two things, na? Additivity and scaling. Okay, so can you say this? Okay, I don't know. The system may be linear, may not be linear, right? Na? Okay, so can I say that? Not sure. What I will say here is I'm not sure. I don't deny also, but I'm not sure. I cannot conclude because I cannot apply scaling here. System may be linear, may not be linear. Nothing is mentioned. Okay, nothing is mentioned. Okay, now, but it is time invariant. So that property can be used. Okay, so can there be any input out of X1, X2, X3 and X4 which can be converted to impulse, unit impulse without any scaling? Okay, but only shifting allowed. Time invariance is dealing with what? Time shifts in the input. A time shift in the input should give a similar time shift in the output, right? So see here, okay, 3, amplitude 3, 2, 3 will not work, but this is having amplitude 1. Okay, this is like a impulse. This is like a shifted impulse signal. This is definitely like a shifted impulse signal. So what about the signal X3n? Sorry, this is X4. Okay, it has only the value 1. Every 1 point signal is an impulse, but the value 1 is at what value of time? So arrow means origin. Arrow means origin, so n equal to 0, 1, 2. So there is the value 1 at n equal to 2. That means it is the impulse at n equal to 2. Delta n minus 2. And unit impulse. Okay, unit impulse. Clear? Right. So now the point is, let us take it here. Okay, the input X4n given to me is delta n minus 2. Okay, now see, if del n, if the input is del n, okay, once again let me rewrite. If the input is del n, then the output is Hn. That is known as impulse response. Okay, so now if the input is del n minus 2, what is the output now you expect? Output is given to you y for n, but what is the output I accept? Del n has hn, so del n minus 2 has the output hn minus 2. Why? Because the system is given to you as time invariant. A time shift in the input will produce a similar time shift in the output. Pure concept question. If your concepts are clear, then it is very easy. Okay. And that too, very careful, it is only mentioned as time invariant, not linear. Okay. So output y for n is hn minus 2, and output y for n is actually given to me. Output y for n is actually given to me. That should be h of n minus 2, and output y for n is given to me as 0, 0, 3, 2, 0, 0, and this is the origin. So dear, what should be hn? Okay, if I want hn, here I should do n plus 2. Here I should do n plus 2. Then n plus 2 minus 2 will give me hn. So y for n plus 2. Now what is y for n plus 2? What is y for n plus 2? Left shifting. What is y for n plus 2? Left shifting of the output. It is known as left shifting of the y4. Okay. So left shifting, what will be the effect of left shifting? Okay, the entire signal has to be left shifted by 2 units. Okay, so all these values will further left shift. Okay, whatever is the value here, okay, left shift the signal, or equivalently right shift the arrow. Okay, the arrow will go here. Okay, this is what is the impulse response of the system. Okay, which has the value 3, 2. Okay, at n equal to how much? If this is origin, this is n equal to minus 3 and minus 4. No, origin value will not be 3, na? You don't left shift the arrow, dear. You have to left shift y for n. Harsh, clear? Okay, so, yeah, correct it is. This is what should be the answer. All the value will be further left shifted, na? Y for n plus 2 has to be created, right? Yeah, perfect. Yeah, done. This is what is the answer. Okay, fine. Next question. That will be pure conceptual. Good question, but okay, good question. Next, consider the following statements related to the impulse train with the interval of 10 seconds defined as there is an impulse train mt summation minus infinity to infinity delta t minus 10n. Okay, and it's a MSQ question. The trigonometric Fourier series coefficients are what? The exponential Fourier series coefficients are what? Okay, so see, what is this impulse train? Let me simply draw it. Okay, very simple case it is. It is given by summation delta t minus 10n. Summation delta t minus 10n. N is equal to minus infinity to the infinity. So better let's draw this impulse train quickly. It's better to draw this impulse train quickly. It's better to draw the impulse train quickly. Okay, so if you take n equal to 0, so there is an impulse at origin, del t, there is an impulse at origin. Then directly when you take the n equal to 1, there is an impulse delta t minus 10, that is a shifted impulse at t equal to 10. Okay, then at t equal to 20. Then at t equal to 30, etc. N equal to minus 1, so there is an impulse delta t plus 10, left shifted impulse at minus 10, and etc. Clearly periodic signal. Okay, clearly periodic signal, and simple one only. Okay, so let me mark the one time period as minus 5 to 5. Okay, one time period as minus 5 to 5. The time period is 10. Okay, or you can call the time period from origin to 10. Okay. Now dear, what is the exponential Fourier series coefficient? What is the CK formula? Okay, no need to solve both separately. Suppose if I start with the basic CK formula, CK is given by what formula? 1 upon t integral over one time period xt e power minus jk omega naught t dt. Okay, now integral over one time period, that is minus t by 2 to t by 2. Okay, so that means 1 upon t, time period is 10, but integral over one time period, that is integral minus 5 to 5. But within minus 5 to 5, within one time period, there is one impulse. Okay, that is unit impulse del t. then at unit impulse del t, e power minus jk omega naught t dt. If required, omega naught I will put down, but that is actually not going to be required, because again, the property of impulse will come, integration with impulse will come. Integration with impulse will come. Correct, dear? Okay, so what is the integration with impulse going to be? See, 1 upon t. Now, e power minus jk omega naught t at the location of the impulse. The impulse is at 0. The answer is e power minus jk omega naught t at t equal to 0. Okay, which is e power 0, and answer is simply 1 upon 10. Time period, which is 10. Okay, ck is 1 by 10. So definitely option number D. The ck is 1 by 10. Okay, and then what is the relation of ak bk with the ck? Bk definitely is 0. Yes, Harsh, correct, because it's an even symmetric signal. Okay, so it will not have sign terms. It will not have sign terms. Okay, so bk is 0 by that logic. Or if I write down simply the relation between them, if I write down the relation, see, trigonometric Fourier series coefficient ak, you should know it. It is ck plus c minus k, and bk is given by j into ck minus c minus k. Now, what is ck? Okay, what is the ck? 1 by 10. Okay, so 1 by 10 plus 1 by 10, c minus k. Ck is constant. Okay, so c minus k is also 1 by 10. It is constant. So 1 by 10 plus 1 by 10 is 2 by 10 or 1 by 5. But this is going to be 1 by 10 minus 1 by 10, and that is 0. Okay, that is 0. Okay, so bk will be 0. Ak will be 1 by 5. Okay, ak 1 by 5, bk 0, option number B, and exponential coefficients are option number D. Correct, dear? Okay, so the correct answer is B and D, and this was a MSQ question. Correct. Yeah. Next question, dear. Let's be ready for the next question. Here it is. Consider the function. Okay. Consider the function h omega equal to h1 omega plus j h2 omega, where h1 omega is an odd function, h2 omega is an even function. The inverse Fourier transform of h omega is how much? The inverse Fourier transform of h omega is how much? How much means it satisfies what type of symmetry? It's a symmetry based question. It is actually a symmetry based question. So let's solve it. Let's try to solve it. The symmetry based question. Okay. So again, symmetry is an important properties. As I told you, all important models I have taken today. Okay. It is given the h omega is broken as h1 omega plus j h2 omega, imaginary and real part. Okay. Now h1 omega, an odd and even symmetry. So let me first apply h of minus omega. What is h of minus omega? H of minus omega will be h1 minus omega plus j h2 minus omega. Correct, na? h1 minus omega plus j h2 minus omega. Correct, dear? Now, that means h of minus omega will be, what is h1 minus omega? So, h1 omega is an odd function. Because it is an odd function, h1 minus omega should be minus h1 omega. Correct? And h2 minus omega. Now, h2 is an even function. Because h2 is an even function, so h2 minus omega is the h2 omega. Is the h2 omega. Minus h1 omega plus j h2 omega. Minus h1 omega plus j h2 omega. Correct? Okay. Next. Next. Okay. Now, if I take minus common, I can write this as h1 omega minus j h2 omega. Okay, so this now look like h minus omega is minus of, if h1 plus jh2 is h omega, h1 minus jh2, conjugate of h omega. So conjugate antisymmetric. Conjugate antisymmetry is coming up here. Conjugate antisymmetry. What I am able to say here, h of minus omega is negative of h omega. If a signal is real, Fourier transform is conjugate symmetric. If a signal is pure imaginary, Fourier transform is conjugate antisymmetric. Okay, what is the Fourier transform here? Conjugate antisymmetric. What is the Fourier transform here? Conjugate antisymmetric. conjugate antisymmetric. Okay, that means the signal in the time domain ht, when you take the inverse Fourier transform, you go to the time domain. Okay, the signal ht must be pure imaginary. Must be pure imaginary. Must be pure imaginary. Or otherwise you recall your property. You recall your property. See, h minus omega is whose Fourier transform? H minus t. H minus omega is the Fourier transform of h minus t. Or let me write it this way actually to make it more simple. Okay, what is h omega? Okay, I'll shift the minus on the other side. What is h omega? Minus h conjugate minus omega. Now that means h omega is the Fourier transform of ht, and that ht is equal to how much? Okay, h conjugate minus omega is the Fourier transform of conjugate of the signal. Okay, it is minus h conjugate t. Okay, a signal is equal to negative of its conjugate, z equal to minus z bar, when z is pure imaginary. When z is pure imaginary. Okay, so option number C, pure imaginary. When the conjugate of the number is equal to the number, that is a real number. Conjugate of the number is negative of the number, that is valid for pure imaginary cases. That is valid for pure imaginary cases, right? Na? So correct answer C, pure imaginary. Okay, or directly you can remember, if a signal is real, Fourier transform conjugate symmetric. So if a signal is pure imaginary, Fourier transform is conjugate antisymmetric. Conjugate antisymmetric. Okay, option number C, correct answer. Yes, Harsh, correct answer. Option number C it is. Okay. That's it. Okay. Only pure imaginary, not odd. Okay. Because if the signal was odd, Fourier transform should also follow odd symmetry, but that is not applicable here. Okay. Next question. Number 9. What is the Fourier transform of the signal shown below? This is fundamental only. This is fundamental but yet expected, because questions around rectangular signals are always expected. Okay, so these are two different, you can call it as a band pass case given. It's a time domain, although just take it as two different rectangles. Two rectangular pulses are given to you. Okay, now you first only take a single rectangle. Okay, width of both the rectangles is 1, amplitude is 1. Only difference is you just have to take this signal, I think. If you just take this signal, let me draw it here. Consider, suppose this signal xt. Consider this signal xt. And what is that signal xt? Width is total width 1. Na? So let me take minus 1 by 2 to 1 by 2. Only difference is, let me make the center as 0 first of all. Symmetric rectangle. Let me make the center at 0. Minus 1 by 2 to 1 by 2. Width is 1. Amplitude also 1. So what type of signal it is? It is rect of t. How much is the width? 1. Okay, no, because normally when I write rect t by t, normally when I write rect of t by t, what is the meaning of that rectangle? Okay, it is a symmetric rectangle centered at origin and having a total width of t. Having a total width of t. So here, how much is the total width? 1. How much is the total width? 1. Okay. Now dear, what is the relation between this and this part? What is the relation between these two parts? Same rectangle of same amplitude 1 and same width. Only thing is its center is at 1.5. Center is at 1.5. That means when you right shift, if you just right shift to 1.5, okay, you will get this part. So what is this signal equal to? Okay, if the above one is rect of t by t, t is capital T is 1, so only rect t, you shifted by 1.5. Similarly, you left shift by 1.5, center becomes minus 1.5. Same width and same amplitude, same rectangle is obtained. So what is this part equivalent to? This part can be written as a rectangular signal, left shifted rectangular signal, left shifted by 1.5. So I can write it as rect of t plus 1.5, right? I can write this as rect of t plus 1.5. Okay, so now what is the signal yt? Okay, first of all, before I write yt, what is the important Fourier transform pair? Rect of t by t has the Fourier transform t sampling omega t by 2. It has the Fourier transform t sampling omega t by 2. So what about rect t? When the capital T is 1, the Fourier transform becomes sampling omega by 2. Okay, what I am looking for? Rect t minus 1.5 plus, there are two parts of the signal, Rect t minus 1.5 plus rect t plus 1.5 is the signal yt. Question is, what is the Fourier transform of this signal yt? Okay, let me do it. What is the Fourier transform of this signal yt? What is the Fourier transform of this signal yt? So that is y omega. Now what is rect t Fourier transform? Time shifting property will be applied. Rect t Fourier transform sampling omega by 2. So rect t minus t naught. Time shift will give a phase shift in the frequency domain or exponential term e power minus j omega t naught. T naught is 1.5. Okay. Plus sampling. Okay, again rect t sampling omega by 2 and rect t plus 1.5, so e power plus j omega 1.5 plus 1.5 omega is the phased term, is the phase shift that is going to come up. Okay, so very clearly what is common from these two terms? Sampling is common. Okay, take the sampling function outside and then you have, then what do you have? E power minus j theta plus e power j theta. E power minus j theta plus e power j theta is known as 2 cos theta. That is known as 2 cos theta. So what is the y omega as of now? It is 2 sampling omega by 2. Sampling omega by 2. Okay, and cos theta. Cos of 1.5 omega. E power j theta plus e power minus theta is 2 cos theta. Okay, so 2 cos of 1.5 omega. Okay, so okay, two things. Now options are in sync format and the frequency f domain. No problem. No problem. First of all, what is the relation between sync and sampling? Okay. What is the sync theta function? Can be written as sampling pi theta, right? Okay. So if I want to write down sampling in terms of sync, I will write it as sync theta by pi. Okay. So let me first convert this to the sync. So it becomes 2 sync of omega by 2 pi. I'll divide by pi. Omega by 2 pi cos of 1.5 omega. Now I want in the f domain. That's also not a problem. Okay, let me just rewrite. What is the y omega obtained? 2 sampling omega upon 2 pi cos of 1.5 omega. Okay, so what is going to be the yf? In the frequency f domain, we know that omega is 2 pi f. Okay, the y 2 pi f or simply yf, the f function will become, sorry, this was sync. Already I converted it to the sync. Yeah. Okay, omega is 2 pi f. So 2 pi cancel. It is going to be sync of f into cos of 1.5 into 2 pi f. So cos 3 pi f. Sync f cos 3 pi f. 2 sync f cos 3 pi f. So option number A is ready for you. Okay, so option number A, correct answer. Okay, next question. If x omega is the Fourier transform of real and non-negative signal xt, and we are given the facts that f inverse 1 plus j omega x omega is equal to k e power minus 2t ut, where k is a positive constant and integral minus infinity to infinity mod x omega square d omega is 2 pi, then what is the signal xt equal to? Then what is the signal xt equal to? Again, it's a good question on Fourier transform. Have a look into this. If x omega is the Fourier transform of a real and non-negative signal xt, and we are given the facts that f inverse, okay, that, see, I'll start with this fact. What is given? F inverse, that is the inverse Fourier transform of 1 plus j omega multiplied by x omega is given by k e raised to the power minus 2t ut. So that means 1 plus j omega is multiplied by x omega is given by Fourier transform of k e power minus 2t ut. K e raised to the power minus 2t ut, correct? k e raised to the power minus 2t ut. Okay, so what is the Fourier transform of k e power minus 2t ut? That we know na. Okay, so what is 1 plus j omega into x omega can be written as e power minus 80 ut, bounded exponential signal. Okay, e power minus 2t ut, 1 upon a plus j omega, that is 1 upon 2 plus j omega. Okay, that is k upon 2 plus j omega, correct? K upon 2 plus j omega. Okay, so what is x omega? So now we have some information on x omega. That is k upon 1 plus j omega into 2 plus j omega. 1 plus j omega upon 2 plus j omega, where k is unknown. Maybe for k only we have been given this result. Okay, let's see how to use this result. Okay, first of all, okay, if I want the signal xt, see what is x omega? Let me rewrite. It is k, or let me put it this way. It is k into 1 upon, first let me split it into partial fraction normally, 1 upon 1 plus j omega, 2 plus j omega, and this should be broken as simple partial fraction, I guess. 1 upon 1 plus j omega, simply subtraction is working here, minus 1 upon 2 plus j omega, because 2 plus j omega minus 1 plus j omega cancel, 2 minus 1, this will be 1, correct? So this is what is x omega. So what is the signal xt? Okay, k constant, 1 upon 1 plus j omega, e power minus t ut, 1 upon 2 plus j omega, e power minus 2t ut. Okay, so ut I take common. Okay, so k e power minus t minus e power minus 2t ut. Okay, right. So, but what is k? I mean, e power minus t minus e power minus 2t format is there, but k root 12 or none of them is also there. So we can't only say that the option number A is correct. Okay, so what is the correct answer now? How to find the value of the k? How to find the value of the k? So see what is given here. This information which is given, it is nothing but the Parseval's relation. Okay, what is the energy of the signal? See, what is the energy of the signal? Parseval's relation. There are two ways to calculate energy. Integral minus infinity to infinity x square t dt. Okay, integral minus infinity to infinity x square t dt. Okay, or by the Parseval's relation, the same is equivalent to 1 upon 2 pi integral minus infinity to infinity modulus x omega square d omega. Okay, and this integral value, integral mod x omega square d omega, is given by 2 pi. So 1 upon 2 pi into 2 pi is 1. 1 upon 2 pi into 2 pi is equal to what? Is equal to the 1. Is equal to 1. 1 upon 2 pi into 2 pi is equal to 1. Correct, dear? Okay, so energy of the signal is 1. Okay, from that somewhere, k can be worked out. Okay, so now energy, that means I have the time domain information, integral minus infinity to infinity x square t dt, this should be 1. Okay, so integral minus infinity to infinity x square t, that is k square, into e power minus t minus e power minus 2t whole square dt, and the signal has been multiplied by ut. So for ut I will change the limit actually. Okay, so 0 to infinity. Okay, so this integration should be 1. We have to complete this integral. This integral should be 1. Okay, so k square, then e power minus t whole square, e power minus 2t. Okay, then e power minus 2t square, so e power minus 4t, so a square plus b square minus 2ab. Okay, so minus 2ab, when you multiply these two, the power getting added, e power minus 3t dt. This is how the value of the integral is. K square. Okay, then e power minus 2t integral, e power minus 2t upon minus 2, e power minus 4t integral, e power minus 4t upon minus 4, and minus 2 e power minus 3t integral is e power minus 3t upon minus 3, limit 0 to infinity. This should be equal to 1. Okay, So k square. Now you see the upper limit, dear. For all of them, upper limit is 0, 0, 0. E power minus infinity is 0. Okay, e power minus infinity is 0. So now directly coming to the lower limit. E power 0, 1. Okay, so minus 1 by 2. 1 upon minus 2. Then minus 1 by 4. And this also e power 0, 1. Okay, so minus minus, this is plus 2 by 3. This is whole equal to 1. That means k square now, open this bracket, minus minus, plus 1 by 2, plus 1 by 4. And minus 2 by 3, actually this is 1. Okay, so definitely the LCM here is 12. Okay, so then this is 6 and then this is 3 and minus 8. Yes. Okay, so 9 minus 8, 1 by 12. K square is equal to 12 and hence k is root 12, and I think that is what is in the option number A. K is root 12, option number A. Option number A. So some good question this is. Okay, we will not say it as a very direct question, not a difficult one, but good. You have to connect the dots, you have to connect the points. Basic Fourier transform pairs along with a Parseval's result calculation. Okay, where Parseval's is also displayed, but actual energy calculation goes in the time domain by integral x square t dt. Done, dear? Correct, Harsh. Option number A is coming up. Option number A is coming up very clearly. Not a doubt, not a problem. Okay. Next question then. Okay, this was the 10th done. 11th question. Here it is. MSQ again. 11th one is a MSQ question in nature. If xt is equal to 5 plus 2 cos 4 pi t be periodic signal, then what is the energy of xt? Average power of the signal xt, total power present in the DC component and second harmonic, and frequency of fifth harmonic. Okay, of course it's a periodic signal. Okay, so energy always will be infinity. That is correct. That if you know the fundamentals, okay, you can directly say. And what is the total? Its periodic signals are generally power signals, and it has two components. One is DC and one is a sinusoidal term. Okay, so what is the power corresponding to the DC? Okay, what is the power corresponding to the DC? Okay, corresponding to the DC, if there's a constant amplitude A, the power is simply given by A square. Okay, it is simply given by A square, that is 25, and corresponding to the sinusoid, the average power, okay, the average power will be given by amplitude square by 2. Okay, the average power of sinusoid A square by 2. Okay, so that is equal to 2 units. Okay, so the total average power is 27, correct. Total average power is 27, 25 and 2, correct. That is correct. The B is also correct. It's a power signal, so energy will be infinity. A also correct. A also correct. What is the frequency of fifth harmonic? Let's come to a simple part. So what is the fundamental frequency? What is the omega naught? Okay, what is the omega naught is 4 pi. Okay, or what is the F naught? Okay, in hertz, if you take divide by 2 pi, that is 2 hertz. So what is the frequency of fifth harmonic? For any nth harmonic, frequency is n F naught. So for fifth harmonic, it is 5 into F naught, and 5 into 2 will be definitely 10. Definitely 10. So option number D is also correct. Okay. Now C option, the total power present in the DC component and second harmonic. Okay. How much is the total power present in the DC component? I already told you, 5 square, 25. And how much is the total power in DC and second harmonic? Okay. Now, is there going to be any second harmonic? It has DC component either zero frequency or it's a sinusoidal term. Sinusoidal are single tone terms. It will only have, okay, the fundamental frequency term. It will not have harmonics. It will not have harmonics. Okay, see, D option is different. Frequency of fifth harmonic. The amplitude of fifth harmonic would be 0. Okay, the frequency for any harmonic can be defined. The fifth harmonic will also be not there. Okay, will also be not there. Okay, will also be not there. Okay, but what about the second harmonic? What about the second harmonic? There is no second harmonic. Okay, because it's a sinusoid, single term tau. Okay, it can only be represented as directly 2 cos theta e power j 4 pi t plus e power minus j 4 pi t. Okay, only the 4 pi, that is the fundamental frequency, only the harmonic terms will be there. The fundamental frequency term will be there, I mean. Okay, so there is no second harmonic. Okay, and since there is no second harmonic term, okay, there is no power in it, and the total power in DC and second harmonic is what is there in the DC, 25 watts. C is the correct answer. C is the correct answer. Yes. So A, B, C, D all correct. C is also correct then, Ashutosh, right? Correct. Second statement is incorrect. No, Harsh, which second statement is incorrect? Please, can you elaborate? See, Avinash, first of all, this is average power calculation, and this is, of course, the general idea. If you take any two signals, whether it is energy or power, okay, A plus B whole square will come, A square plus B square plus 2AB, but it has been derived. This is a very standard result, okay, addition of two sinusoids or addition of a sinusoid and a DC. Okay, so that's what you can note it as a standard result. Avinash, I am not deriving it, that yes, if it is sinusoid plus DC, the average powers can be directly added without the need of that 2AB term. Okay. After deriving, it has come up. Okay, clear na? This can also be looked up with respect to Parseval's. Can also be looked up with respect to Parseval's. Second harmonic not present. That is why total power in DC and second harmonic combined will be same as what is there in the DC, Harsh. Correct na? Yes. Okay. Yes, Ashutosh, next question is coming. Exactly, Arif. That is what correct. It is orthogonal to, okay, this sinusoid signal, basically. Okay. Coming up next, again MSQ question. Yes, Avinash, I was replying to your doubt only for the past. I was replying to your doubt only, Avinash. You can also listen to it once again. Yes, sir. Come up. Next. Xt is a band limited signal with the bandwidth b radian per second. With the bandwidth b radian per second. Okay. With the bandwidth b radian per second. Come up here. Okay. Now, xt is a band limited signal with the bandwidth b radian per second. Okay. And, it is then multiplied by some carrier waveform cos omega ct, then to produce a signal gt, which is passed through a low pass filter having the frequency response h omega given to you. Okay, and then it produces some output yt. Okay, which of the options are correct? MSQ question. Which of the options are correct? Okay, let's have a look into this one. So what is gt first of all? What is this gt first of all? Gt is xt into cos omega ct. Okay, cos omega ct. Okay, so xt has some absolute bandwidth given to you, b radian per second. Okay, b radian per second, band limited signal having the bandwidth b radian per second. Okay, though what is the spectrum of gt, and then it is passed through a low pass filter h omega. You can even draw this h omega. It is just an ideal low pass filter. Why? Because if you draw this h omega, it is 1 for mod omega less than omega c. That means omega, any value from minus omega c to plus omega c, the h omega is constantly 1, and this is then known as the cutoff frequency. And this is nothing but an ideal low pass filter. Why ideal low pass filter? Because any frequency up to omega c is passed with the constant gain 1, and any frequency thereafter is rejected. Okay, thereafter is rejected, correct? Okay, fine. So now what is the GT? Okay, what is the GT? Okay, so let's say xt has some Fourier transform. Let us say xt has some Fourier transform x omega. Okay, it is a band limited signal with the bandwidth b. Okay, so any Fourier transform you can assume here as an example. It's not given, but let me assume as a band limited signal Fourier transform which is limited in frequency bandwidth, the bandwidth being b radian per second. It's given in radian only. That means we can take the Fourier transform any shape between minus b to b. Any shape between minus b to b. Okay, correct. Now, if xt has the Fourier transform x omega, what about the gt? gt is given by what? xt cos omega ct. xt cos omega ct. Now, the important point is that the frequency of this carrier signal is same as the cutoff frequency of the filter. Okay, so cos omega ct. What is the Fourier transform? First of all, g omega. Okay, modulation property. If any signal multiplied by cos, its spectrum is shifted to higher frequency centered at plus minus omega naught, x omega minus omega c plus x of omega plus omega c whole divide by 2. Okay, whole divide by 2. Okay, so let me draw the spectrum g omega here. Let me draw the spectrum g omega here. What is the g omega? X omega minus omega c. Please right shift to omega c. Please right shift it to omega c. This is omega c. So this should be omega c plus b and omega c minus b. And also left shift to omega c. So then this is minus omega c minus b. This is minus omega c plus b. Something like this. Okay. Right. And amplitude divide by 2. Okay, whatever, if the amplitude here was a, it should be a by 2. That doesn't matter a lot here. But now this gt having the Fourier transform g omega is passed through an ideal low pass filter. It is passed through an ideal low pass filter. Okay, so if I just place the low pass filter also here. Okay, if I place that low pass filter window also here. This is what is that ideal low pass filter. And what is the role of the low pass filter? Any frequency up to the cutoff frequency will be passed as it is. Okay, so what is the ideal low pass filter output? I'll draw it here separately. What do you see in the output? Okay, in the frequency domain, let's say the output is y omega, because in the time domain they have called it as yt. So what is going to be y omega? See here. Y omega will be, okay, this half triangle this side and this half triangle this side. Okay, this is y omega. Now, correct? All analysis done. Now, let's see the option. Ricky says D. See, is the yt 0? If the yt is 0, y omega should be 0. That is not 0. Correct. Y omega not equal to 0. So, this is wrong. Is the yt equal to xt? This is also wrong, because if yt equal to xt, y omega should be x omega. Okay, this is x omega. Is the y omega same as x omega? No, the y omega not equal to x omega, then yt cannot be xt. So A and C are wrong. What about GT? GT, is it a low pass signal or a band pass signal? So GT means it has the Fourier transform g omega. Okay, it has the Fourier transform g omega. Forget the low pass filter. Okay, this Fourier transform is a band pass signal. It passes the band of frequency from omega c minus b up to omega c plus b. Okay, so g omega is actually a band pass signal, not a low pass signal. Option number D, the correct answer to the question. Although it is MSQ, but still one option correct. And there have been instances in the GATE exam also. Right? MSQ, but one option correct. Okay, so that is the reason I have taken such a case. MSQ, but only one option correct. Okay, the correct answer is D. Yes, Ricky, correct answer. Harsh, correct answer. D is the very correct answer. Next. A signal xt band limited to W. Okay, band limited to W hertz, and there is a signal yt which is x cube t plus xt plus 1. What is the Nyquist sampling frequency of yt? No, Ricky, it is still a MSQ question only. MSQ means even one option correct also is a possibility. That is the reason I clearly mentioned it as MSQ. You have to be ready. And evenly previously there have been questions in GATE. It was MSQ, but only one option correct. Right? MSQ only. Okay, next question, dear. Okay, so what is the next question? Signal xt is band limited to w hertz and the signal yt x cube t plus xt plus 1. What is the Nyquist sampling rate, Nyquist sampling frequency of yt? What is the Nyquist sampling frequency of yt? Nyquist sampling frequency of yt. Have a look into it. See, first of all, if the signal xt is band limited to w, that means if I take the bandwidth is w, okay, if xt has the bandwidth of w, if xt has a bandwidth of w, what about x power nt? X power nt, it will have a bandwidth nw, isn't it? It will have a bandwidth nw. These are standard results to be known to you. And then one is just constant. When you convert to the frequency domain, the Fourier transform of 1 is 2 pi del omega, only a impulse at origin, so ideally no bandwidth. Okay, and when then two signals are added, okay, yt, which is x cube t plus xt plus 1, okay, what's going to be the bandwidth for this? X cube 3w. Okay, but when signals are added, bandwidth is the maximum of them, maximum of any of the case. So x cube 3 bandwidth 3w, xt has the bandwidth w, and 1 will not have any bandwidth. Okay, so it's only height of 3w or w. Okay, that is 3w. The maximum of them is 3w. Okay, so for the signal yt, the overall bandwidth is 3w. So what is the Nyquist rate? Nyquist rate is twice of this. Okay, the Nyquist sampling rate will be 6w. Option number B. Correct. This was simple usually. This was a simple. Correct. Option number B. 6w. Yes, Gaurav, the 6w. Next. For the signal xn equal to -1 0 1 2 1 0 1 2 1 0 -1, MSQ question again. Okay, what are the correct options? X e power j0. Okay, now x e power, see, the signal xn has some dtft x e power j omega, or simply you can call it as x omega also. Okay, so what is the value of, now see, what is the dtft formula? Okay, if I write down the dtft formula, na, x omega, it is simply summation of xn e power minus j omega n. So when I want x0, option number A is talking about zero frequency. It is nothing but a standard result. It is the summation of xn. It is summation of xn. And if I go to the, I'll do the summation, and if I go to the IDTFT property, if I go to the IDTFT formula, basic formula, what is IDTFT? It is given by 1 upon 2 pi integral over one time period, that is minus pi to pi x omega e raised to the power j omega and d omega. Correct? Right, dear? Isn't it? Let's check out now. Okay. Ricky, around 9 to 10 is usually expected marks from signals for EC. Okay, it may be a little bit more or less also, but that is what 9 to 10, the expectation has to be there. So yes, option number A. Option number A, you say for which question? Gaurav and Harsh, are you calling it for previous one? No, previous one was 6W. Okay. Or for this question, where do you say option number A? Okay, let's see. It's a MSQ question. So summation xn, first of all, what is x0? Is summation of xn. So summation of xn, -1 plus 0 plus 1, okay, plus 2 plus 1 plus 0 plus 1 plus 2 plus 1 plus 0 plus -1. Okay, and that is equal to this part cancel, 2 plus 1, 2 plus 1, yes, 3, 6, correct. Option number A is at least correct. Okay, right, option number A. Okay, Harsh and Gaurav for this one. Now let's see any other option. So xn, now if I want x0, coming to the IDTFT, if I want x0, so x0 is 1 upon 2 pi integral minus pi to pi x omega d omega. Why? Because if you put n 0, again e power 0 1. Okay, so option number C can be figured out from here. Okay, integral x omega d omega. Integral x omega d omega from minus pi to pi is nothing but 2 pi x0. Okay, 2 pi x0. Now, what is the value of the signal at origin? X0 means the value at origin, which is 2 units. Okay, so 2 pi into 2 is 4 pi. Okay, so 4 is not correct. 4 is not correct. 4 pi is the correct answer. So C option not correct. A correct. A correct. Now B and D, integral minus pi to pi mod x omega square d omega. Again Parseval's theorem. Again B or D, any one will be correct, and that is as per the Parseval's theorem. So let's check out what is the Parseval's theorem again. Okay, if I talk about the energy of the signal in the time domain, since it's a real signal given to me, I can write down the energy as minus infinity to infinity x square n summation of the square of the signal, and same as per the Parseval's relation is equivalent to 1 upon 2 pi integral over one time period, that is minus pi to pi mod of x omega square d omega. Okay. So option number B or D is talking about this integral mod x omega square d omega, which comes in the Parseval's. So from the Parseval's reverse, I can write integral minus pi to pi mod x omega square d omega should be equal to 2 pi times energy of the signal, that is 2 pi summation x square n, summation of the square of the signal. Okay, summation of the square, minus 1 square 1, then 0 square, then again 1 square. Next is 2 square, which is going to be 4. Next is 101, the square will also be 101. Next is 2, square is 4. Next is 10 minus 1, but minus 1 square also will be plus 1. The next pattern is again 101. So now I have to just count the total. 2, 4, 6, 7, 8, 12, 13, 14. 2 pi into 14. So yes, 28 pi. 28 pi. 28 pi means B wrong, but D correct. Okay. So overall options, option number A, option number D correct for this MSQ question. Option number A and D correct for this MSQ question, right? Okay, fine. Okay, next question. 15th. What is the two-sided Laplace transform of the signal? Basic, fundamental. Okay, it's a fundamental question. Two-sided Laplace transform. Two-sided means bilateral Laplace transform. So when I take any signal e power minus at ut, it's on the two fundamental cases, one right-sided, one left-sided. E power minus at ut, what is the Laplace transform? 1 upon s plus a, but with the ROC, sigma greater than minus a. If I take e power minus at u of minus t, left-sided, the Laplace transform minus 1 upon s plus a. Same formula, only minus difference, but ROC is left. Sigma less than, ROC reverse, sigma less than minus a. Correct? Right. I just told Ricky 9 to 10 marks is what you can expect. Okay, for EC. Now, for the given signal xt, now using both the cases, okay, for the given signal xt, what is the Laplace transform xs that can be written? For e power minus 3t ut, for e power minus 3t ut, 1 upon s plus 3, but for sigma greater than minus 3. Okay, if two signals are added, the Laplace transform added linearity. E power 2t u minus t formula, so minus 1 upon s plus a, e power 2t. So if you compare with this form, a will be minus 2. A will be minus 2, so s minus 2. Okay, and sigma less than minus a, so sigma less than 2. Okay. Now, when two signals are added, two Laplace transforms are also added, and because two Laplace transforms are coming together, you have to make both the ROCs happy. That means you have to take the intersection of both the ROCs. Okay. Okay. So, when I try to add them, what is going to be answer? S and minus s will cancel. Minus 2, minus 3, minus 5 divided by, when I multiply the denominator, s plus 3, s minus 2, so s square. Okay, plus 3 minus 2, so plus s, 3 into minus 2, minus 6. Okay, with what the ROC should be? Sigma greater than minus 3, but sigma less than 2. Okay, so sigma greater than minus 3, but less than 2, that means it is between minus 3 to 2. It is between minus 3 to 2. Okay, so what is the correct answer then? Minus 5 upon s square plus s minus 6 minus 3 to 2 is the ROC. Minus 3 to 2, option number A. Minus 3 to plus 2, option number A. Correct answer, Ashutosh. Yeah, Harsh, correct. Arif, correct. A. Only by ROC also you can say. Correct. Here you can say by ROC also, but sometimes they can change the expression also, not a problem. Okay. Gaurav, for statement, yes, from signal statement based questions are definitely coming. Only thing is, go through your notes clearly. Whatever is there, it's all out of the concepts you learn. It's nothing different. Okay. So for signals, either you have numericals or statement based MSQs. For that, your theory, your concept part should be clear. Okay. So go through the theory carefully. Revise your notes carefully once, especially all the important bullet points that you might have noted in the while you making the notes or while you were attending the class. Okay. Yes, Pavan, correct answer A. So this was simple one. This was simple and fundamental one. Next question, number 16. A discrete time signal xn is given to you, minus 1 by 3 power n un. Consider another signal yn and its z transform yz given as yz equal to x of z power 4. What is the value of yn at n equal to 5? What property? What property? X of z power 4. Okay. Madhu, what doubt you are telling? Z is plus 1 for even signal. Okay, have a look into it. Yz is equal to xz power 4. Okay, will come on what property? Okay, will come under what property? See, if xn has the z transform xz, time expansion property, x of n by k, time expansion, specifically will have the z transform x of z power k. So you can use the time scaling property, time expansion to be more specific. Time expansion to be more specific. Okay. So when I say the yz is given to you, when I say yz given to you is x of z power 4, then xn should be x of z power 4 will come when you do x of n by 4. Okay, that means yn, sorry, yz is the z transform for yn. So yn, this should be the z transform for x of n by 4. X of n by 4. Right. Now what is the value of yn at n equal to 5? What is the value of yn at n equal to 5? y5 will be how much? X of 5 by 4. But inside any signal, whether x or y, inside any discrete time signal, time should be integer. For non-integral value, the signal is 0. Right? Okay. No, for even signal, it's not necessary that there will be z transform plus 1 minus 1. No. Okay, there isn't any such thing. There is no any such thing to be specific. Okay. In fact, reciprocal zeros will be there, Madhu, but not symmetric plus minus 1. Reciprocal zeros will be there. Okay, so I think you are not stating any correct statement here. Okay, so what I say, 5 by 4 non-integer, and the dt signal will not exist for non-integer value of time. Answer 0 simply. You don't need to see even the xn. Even if you see xn, okay, but you don't need to see xn here actually because it's a dt. If it was a ct, then I will see the value of the signal xn. So answer is simply 0 here. Answer is simply 0 here. Answer is simply and simply 0 here. Correct? Okay. Yes, done. Okay, even if you elaborate xn and then you expand the signal, the another way is write down the values of the signal xn and then draw the xn by 4. That's the expanded version. Still you will get the answer 0. Still you will get the answer 0. Okay. Yes, Avinash. Correct answer, Avinash. It is 0. Next question, dear. Number 17. MSQ question. A dt system is given to you. A dt system Hz is defined as z plus 1 by 2, z plus 1 by 3 upon z plus 2, z plus 3. Which of the following statements is or are correct? Is it an all-pass system? Is it a minimum phase system? Okay, it is the Hz is stable only when the impulse response is two-sided, or Hz is stable when the impulse response is non-Gaussian. non-causal. Have a look into it. Have a look into it. Okay, let's do it. See, first of all, poles and zeros. What are the poles and what are the zeros? Okay, zeros, z equal to minus 1 by 2, minus 1 by 3. Poles, z equal to minus 2 and minus 3. Minus 2 and minus 3. Okay. Now, definitely poles are outside unit circle. It cannot be minimum phase. It cannot be from minimum phase. All poles as well as zeros must be inside the unit circle. Okay. But whether it is an all-pass system should have symmetric poles and zeros. Symmetry here in dt domain, in the z plane, the symmetry is always about the unit circle. Okay. So this is, if you talk about the zeros, this is 1 into 2, this is 1 by 2. Yes, symmetry is there. This is 1 into 3, this is 1 by 3. Okay, so about the unit circle, symmetry is there. You have symmetric poles and zeros. Okay, for every pole inside unit circle or outside unit circle, there should be a symmetric pole outside or inside unit circle. There are symmetric poles and zeros with respect to unit circle. Okay, and whenever such condition exists, this is all pass. Okay, you don't have to derive it again and again. You should know these conclusions. Otherwise, you convert to the frequency domain by putting z equal to e power j omega, right? And then you calculate the magnitude of the function. That magnitude of the function, what I'm trying to tell you is the magnitude will be 110%. 110% constant for all frequency. That is what is the meaning of all pass. You put z, you convert to frequency domain, you put z equal to e power j omega, calculate the magnitude spectrum. That magnitude spectrum should be constant throughout for all frequency, and it will be if you derive it, but not required. Symmetric poles and zeros with respect to unit circle, all pass system, correct. It's a minimum phase, no. It's a minimum phase, no. I clearly denied earlier only. It's not a minimum phase. It's not a minimum phase because poles are outside unit circle. So it is not minimum phase. It cannot be minimum phase. Okay, so B is wrong. Now, system Hz is stable only when the impulse response is two-sided or non-causal. Now, there is nothing about causality mentioned here. Okay, system may be causal, may be non-causal. So we have to check the ROCs. There are two poles, na? There are two poles. Okay, when the impulse response is two-sided. Now, when the impulse response is two-sided, what is the ROC you will choose? Okay, if a signal is two-sided, ROC is a finite ring. Okay, is a finite ring of finite width between two poles. So what is the ROC? Okay, the ROC in this case will be, what is the mod z? What is the location of the poles? Okay, the 2 and 3. If I take mod z, so ROC can be taken 2 is less than mod z is less than 3. But does it include unit circle? Okay, mod z equal to 1 not included. Unit circle not included. So unstable. Because for the system to be stable, what is the condition? For the system to be stable, ROC should include the unit circle. Okay. Now, Hz is stable if the impulse response is non-causal. Okay. If the impulse response is non-causal. Okay. What is the impulse response being non-causal? Actually, there is a correction here. Otherwise, non-causal also means even the previous case is a non-causal case. Even the previous case is non-causal. I'll correct this actually. I'll correct this. It should be anti-causal to be more specific. Because the previous one is also a type of non-causal. What is a causal ROC? If a signal is causal, ROC is exterior of a circle. Okay, whenever the ROC is not exterior of a circle, whether interior or whether a ring, both of them are considered under non-causal. So when I say non-causal, even the previous case will come. So let me modify the question and let me actually call it as anti-causal. Otherwise, D also will not be generally correct. Now, what is anti-causal? What is anti-causal ROC? Strictly interior. For anti-causal, ROC will be interior, and interior of what? Interior inside of the innermost pole. Inside of the innermost pole. So innermost pole is -2. Okay, so ROC mod z less than 2. Okay. So mod z is less than 2. So mod z can be equal to 1. Yes. If it is less than 2, it can be equal to 1. And when unit circle included, then the system can be stable. So D option can be correct. If I only say non-causal, then D is dicey. Then it is maybe. Okay. Right. right? Yeah, phase is a function of omega, and ideally, Ashutosh, phase should be a linear function of omega, ideally. Okay, for the system to be distortionless. But yeah, phase is some function of omega. Okay, ideally it should be a linear function of omega. Okay, but yeah, as far as only all pass is concerned, what we only check is magnitude being constant. Okay, so D will be 100% correct if I specify anti-causal to be more specific. If it was non-causal, then I think only A option we can mark, and still no problem. MSQ, only one option can also be correct. Okay, can also be correct. Next question, dear. Number 18. Okay, right. Again, a good question. Basic analysis. I mean, concept is to be triggered here. See, the Z transform of a signal xn, the Z transform xz of a real and right-sided sequence xn has exactly two poles, and one of them is at z equal to e power j pi by 2. And there are two zeros at origin. Okay, and it has exactly two poles, and one of the pole is given to you. Okay, one of the pole is given to you. Z equal to e power j pi by 2. What is e power j pi by 2? Cos pi by 2 plus j sin pi by 2. That is only going to be j. Okay, that is only going to be j. That is only going to be j. Now, because the signal is real, we'll come to right-sided next. Whenever a signal is real, what is the property you should know for poles and zeros? Okay, complex poles and zeros will occur in conjugate pair. Okay, this is a complex pole. Okay, so it is a complex pole. So there is another pole at z equal to conjugate of this. That is, what is the conjugate of j? Minus j. Clear? Because the signal is real. Okay, complex poles will occur. Complex poles or even zeros. Zeros here are not complex. Zeros are at origin. Okay, but complex poles or zeros will occur in conjugate pair. That is always true for a real signal. Will occur in conjugate pair. Clear? Okay, so it has exactly two poles. So what is the second pole? Only one pole was given. The second pole is also known. It has two zeros. Okay, so based on this, what is the Z transform structure ready in front of me? What is the Z transform structure ready in front of me? The Z transform, okay, there are two zeros at origin. Okay, so that means numerator should have Z square. Denominator, the poles are J and minus J. So there should be Z minus J and Z plus J term. And also there may be some constant multiplier. There can be a constant term. Okay, only poles and zeros locations are given to me. Okay, so now this is looking like k z square upon a minus b, a plus b, a square minus b square, but j square is minus 1. The denominator is z square plus 1. Can I find the value of k? Because they are asking what is the xz. All the options k looks like 2, but still how to find k? For that x1 is given to you. Okay, for that x1 is given to you. x1 is 1. The value at z equal to 1 is 1. Okay, so if I put z equal to 1, I get k into 1 upon 1 plus 1, and this is 1. Okay, k by 2 is 1, and hence k should be 2. Hence k should be 2. And if k is 2, what is the z transform? 2z square upon z square plus 1. 2z square upon z square plus 1. What about the ROC? What about the ROC? Okay, what about the ROC? So k equal to 2. See, ROC is restricted because of poles. So half anyways will not come, but I'll explain you the ROC in more clarity. Okay, so since k equal to 2 was obtained, xz becomes 2z square upon z square plus 1. Okay, now what about the poles? Poles already we have written plus minus j. That means what is the magnitude of the pole? Both are on the unit circle. Magnitude of j or minus j is 1. Okay, so what should be the ROC? Okay, what should be the ROC? Given the signal xn, now here this point will be used. Given the signal xn is right-sided sequence, and if a signal is right-sided, ROC is exterior of a circle lying outside the poles. So ROC should be either it could be mod z greater than 1 or less than 1. Since it is right-sided, to mod z greater than 1. ROC will be mod z greater than 1. Okay, so option number D is the complete answer that will match. Okay. Okay. Calculation wise, it is 2z square upon z plus 1 and ROC mod z greater than 1. Yes, D correct answer. Yes, Gajendra, correct answer. Harsh, correct answer. Pavan, correct answer. Yes. Yes, Avinash, e power minus j pi by 2 also you can say is the pole, which is nothing but minus j, correct? See, I'll give you the hint for that, Avinash Kumar. You are asking about how to check linear phase. What you do, given any Hn, if Hn is either symmetric or it can be made symmetric by shifting it. By shifting it one time, two time, any time, right or left shift. Okay, if Hn may be not directly symmetric, but if it can be symmetric by shifting it left or right, okay, then it will always have linear phase. Why? You think with respect to Fourier transform shifting property, you will understand. You will understand, okay? So if Hn is given to you, Avinash, and if you shift it left or right anything and it is symmetric after shifting, then it is a linear phase system. Okay, let me know if there is any other confusion. Next question. So this is the 18th one done. 19th. The impulse response Hn, of a linear time invariant system is real. So again some real impulse response is mentioned here. They again mention it is real. The transfer function of the system has only one pole. Okay, so it has only one pole and it is at z equal to 4 by 3. The zeros of hz are non-real and located at, okay, the zeros of hz are non-real, but how many zeros? Nothing mentioned. Okay, and are located at mod z equal to 4 by 3. Mod z equal to 4 by 3, but non-real. Non-real. Okay. Non-real. Excuse me, dear. Okay, and the system is real, and this time the non-real zeros are there. Okay, the system is real and the zeros are non-real, so that means there are zeros. The complex zeros are there this time. Okay, complex zeros now will be in conjugate pair. Will be in conjugate pair because the system is real. The impulse response is real. Clear, everybody? Okay, so the zeros are located at mod z equal to 4 by 3. So what can be the zeros and what can be the poles? There is only one pole and that is z equal to 4 by 3. Zeros. Okay, now zeros satisfy mod z equal to 4 by 3. That means, okay, magnitude is given, so it can be 4 by 3 e power j omega and 4 by 3 e power minus j omega. Only magnitude part is given. Okay, but there have to be complex conjugate poles. So e power j theta conjugate is e power minus j theta. E power minus j theta. So 4 by 3 e power j omega. Okay, and 4 by 3 e power minus j omega. And zeros, how many zeros are there? We cannot confirm. Zeros are non-real. Okay, how many zeros? Minimum 2 zeros. Because if they are complex, they have to be in pair. Okay, so minimum 2 zeros will be there, or it can be 4 zeros. Two different pairs located at the circle mod z equal to 4 by 3. Okay. Why to check zeros for stability? I will tell you. I'll tell you why to check system for stability. I'll tell you because the question doesn't say that it is causal. Okay, it is causal. Just wait why zeros are required. Okay, so that's what is a tricky question here. So, okay, what can be the hz? See, what can be the hz? Zeros. Okay, so this is z minus, suppose z minus z1. Let me call it as z1 and z minus z1 bar. Okay, the conjugate divide, and some constant multiplier can be there, divided by z minus 4 by 3. Or what can be other transfer function? There may be 4 zeros or there may be 6 zeros. Even number of zeros will be there because all the zeros are at mod z equal to 4 by 3. So only pair is possible. Complex conjugate pair is possible. Now, this is required to comment on causality. Why zeros are required? I'll explain you. This is very clear that degree of numerator, degree of, let me call it as some k into some numerator function divided by denominator function. Okay, so degree of numerator is greater than, not even equal, but 100% greater than degree of denominator, and in such a case system cannot be causal, because one of the condition for a discrete time system or a discrete time LTI system to be causal, Of course, ROC being right-sided is one condition, but another important condition for a system to be causal is that the function hz, degree of numerator, must be less than or equal to degree of denominator. The hz must be a proper function, must be a proper transfer function. So degree of numerator greater than degree of denominator, 100% system is non-causal. Okay. Now if the system is non-causal, what is the ROC? Okay, that is non-causal, very clear. Okay, what is the ROC now? So there is only one pole, z equal to 4 by 3. There is only one pole and it is at 4 by 3. So what is the ROC? What is the ROC? Okay, because now there is only one pole, so ROC can be greater than 4 by 3, less than 4 by 3, because you have to make it non-causal. Okay, so mod z less than 4 by 3. I'll take mod z less than 4 by 3. Okay, mod z less than 4 by 3. So definitely it is not going to be causal. Okay, it is not going to be causal. A and C can be removed. Okay, right, A and C can be removed. Okay, it can be anti-causal, correct. Now mod z less than 4 by 3 means strictly less, that is anti-causal also. Okay, but does it include unit circle? Yes. Does it include unit circle? So what is the ROC I am now taking? What is the ROC possible now? Okay, more than mod z less than 4 by 3, and in this case unit circle is also coming. The system is astable and it is strictly interior, so it can be anti-causal as well. Okay, so what is the correct option? It can be stable and anti-causal, option number D. It can be stable and anti-causal, option number D. Yes, option number D. Option number D is the correct option. Okay, so that is why this zero analysis was done, to talk about the degree of the numerator and denominator. Otherwise, if I forget this degree of numerator denominator, then I only say there is one pole at z equal to 4 by 3. So then there are two cases. System may be causal but not stable in that case. If you want to make the system as causal, okay, ROC z greater than mod z greater than 4 by 3, causal, but it will not be stable. Okay, then C option is also correct, but that is what we need to know. It cannot be causal here. It cannot be causal here. Okay. Right, so that is why this is done. So good one. Concept, I have told you the several questions I have taken here which are concept based today. Concept. Of course, they are numerical, but they are very much concept based also, and that is required in signals. The level of question coming, concepts are pretty much required. Okay, next question, number 20, DFT, again a very expected topic. Okay, so what do I have? A finite duration discrete time signal xn is obtained by sampling the continuous time signal xt equal to cos 200 pi t. Xt equal to cos 200 pi t it is, at sampling instants t equal to n by 400. Okay, so what I have first a continuous time signal. I will sample it, okay, by the sampling instant t equal to n by 400. Okay, n is 0 to 7. Okay, the 8-point discrete Fourier transform of xn is given to you. Anyways, DFT formula, you know, 0 to n minus 1 summation xn e power minus j 2 pi by 8 into kn. Which of the following statement is true? Which of the following statement is true? See here. Okay, what is the signal xt given to you? What is the signal xt given to you? It's a fundamental cosine, a sinusoid signal cos 200 pi t. But when I sample it, okay, after sampling, okay, the samples x of nts, or we simply call it as the discrete signal xn, is given by how much? Nts, okay, and where that is n by 400. Okay, that means ts, the sampling time period is 1 by 400. So 200 pi and n by 400. Okay, so what is the xn actually equal to? The xn actually is equal to cos of pi by 2n. Cos of the pi by 2n, correct? The xn is cos of pi by 2n, which will be periodic actually with the period of 4. Okay, but they want to make it as a 8-point signal. Now, what is that 8-point signal? N can take any value 0 to 7. Okay, what here is the condition now? Xn is cos pi by 2n for n equal to 0 to 7. That means what is the signal? They want to create a 8-point signal. So cos 0 is 1. Okay, then cos pi by 2 is 0. Then cos, if you put n equal to 2, cos pi minus 1. Okay, and again cos 3 pi by d 0. And then it will repeat actually, because now you will have next value n equal to 4, cos 2 pi, again 1, then 0, minus 1, 0. 1, 0, minus 1, 0, 1, 0, minus 1, 0. But let me tell you that if you take a 8-point signal and then calculate the 8-point DFT, it's going to be lengthy. Okay, this 8-point signal, okay, what is the 8-point DFT formula? What is the 8-point DFT formula? It is given by xk summation n equal to 0 to 7 x of n. We also write it in the twiddle factor form w8 power kn. Okay, where w8 is given by e power minus j 2 pi by 8. Okay, but calculating 8-point DFT will take time. Will take little bit time. Okay, but what to observe? Okay, that considering this signal which has alternate zeros, consider the signal that is given, it has alternate zeros. If I remove these zeros, what will I now say? Consider another signal after removing zeros. Okay, what is the signal? 1, minus 1, 1, minus 1, 1, minus 1, 1, minus 1. Okay. So what is the signal xn then equal to? Okay. Now the signal I am taking is a 4-point signal. I am taking a 4-point signal, and xn is equal to what? Xn is equal to what? Okay, xn is similar to it. Only thing is alternate zero padding has come up, and zero padding come up. Recall the basic DT concept. Zero padding comes up if you have a signal. When you have expanded signal, when you expand this signal, okay, by 2, okay, when you write down y of n by 2, then the signal xn will come. Okay, when you expand the signal, zero padding will come. 1, 0, minus 1, 0, 1, 0, minus 1, 0. You will be able to get xn. Okay, so now let's find out first the DFT of yn. Okay, let's focus on the DFT of yn. 1, minus 1, 1, minus 1. Correct now? 1, minus 1, 1, minus 1, and let yk be the DFT, which is a 4-point DFT, and that I can do easily. Okay, the 4-point DFT by the 4-point twiddle factor matrix. That's normally what is the basic calculation expected from you. Okay, so the first row is 1, 1, 1, 1, 1 minus 1, 1 minus j minus 1 and plus j, 1 minus 1, 1 minus 1, and 1 j minus 1 minus j. This is what is the 4 cross 4 twiddle factor matrix. 1 minus 1, 1 minus 1 is the signal to be taken. Okay, just yesterday or day before yesterday, I have taken a detailed session on DFT. If you have any doubts in DFT, you can watch it, because DFT definitely is an expected question in EC. Just 2 days back, I think I took that session. Yes. Okay. Complete all properties of DFT and different models of question, and important PYQs were also discussed there. Okay, so first row 1, then minus 1, 1, then minus 1. The first element is 0. Then second row in this column. So 1 and plus j, minus 1 and minus j. So this is also 0 actually. Then 1, minus 1, plus 1. Then again 1 and then again plus 1. So this is 4. Then coming with last row, again 1, minus j, minus 1, plus j. So 0 cancelled again. Okay, so very simple result, 0, 0, 4, 0. Only one non-zero sample. Now dear, the point is, this is yk. Okay, let me write down yk, the 4-point DFT in sequence, 0, 0, 4, 0. 0, 0, 4, 0. Correct? Now see, okay, yn has the DFT yk, and x of n is the actual signal. X of n, which is the actual signal, is y of n by 2. So what is the xk? Okay, time expansion property. If yn has the DFT yk, yn by 2 will have the DFT yk. Replicate the yk, same yk 2 times. If I say y of n by m, yk m times, replica. This is known as the time expansion property of the DFT. I have covered in the DFT class also. Okay, so what is the 8-point DFT xk now obtained? You have to just replicate this answer 2 times. 0, 0, 4, 0, 0, 0, 4, 0. Okay, and now if I write down the different values of k 0, 1, 2, 3, 4, 5, 6, 7. Okay, now let's see the option. Only x4 is non-zero, all xk are non-zero, x3, x5 non-zero. So which of them are non-zero? So I am able to see, na? Okay, right. x2 and x6. These are the only two which are non-zero. Rest all are zero. Rest all are zero. x2 and x6 are non-zero. Option number D then. Option number D. Only x2 and x6 are non-zero. Option number D. Rest all are zero. Correct. So it's a good question using a basic DFT calculation as well as a time expansion property of the DFT. Next question. Next question, number 21, again on the DFT. Number 21 again on the DFT. Yes, Ashutosh, correct. Now have a look into it. Suppose xk is the 6-point discrete Fourier transform of xn. Is the 6-point discrete Fourier transform of xn. Which of the option, okay, which of the following represents yn? Yes, if you trouble in DFT, please watch it, because DFT you should not miss. Almost, I see 100%, so nobody can say IITs are unpredictable, but at least with more than 95% chance I can say DFT question is coming in easy. Worst case if they don't put up, so of course I can't take guarantee, but as per the experience and the trend, 95% or more than 95% chance you are getting a DFT question, and that too for 2 marks. So you should not miss DFT. Should not miss the DFT, okay? It was almost like a 2 hours video day before yesterday with questions with properties. Okay. With questions and properties it is covered. So I think it will be beneficial. On the same Om YouTube channel. See, which of the following represents yn? Which of the following? So see, what is the relation? See, what is the relation between yk and xk? So yk is xk w power. Now what is w6? W6 is e power minus j 2 pi by 6 w power 4k. That means what is the yk? Power will multiply, and yk is xk into e power minus j 2 pi by 6 into k into 4. Now why I am separating it like this? Because this is based on nothing but the time shift property. Only understanding of language has to be there. Okay, what is xn? Suppose if you have xn and the xn has some DFT xk. So what is the DFT of x of n minus n naught? Time shifting. The DFT is given by xk e power minus j 2 pi by n, generally for any length n, e power minus j 2 pi by n into k n naught. How to remember this DFT property? I have explained you in the DFT session. Okay, easy only. So see, this is what is given, e power minus j 2 pi by 6 into k n naught. That means if this is the yk given, what should be the yn? How much is the amount of shift? What is n naught? 4. Okay, so signal xn, when you shift by 4, x of n minus 4. Okay, but what type of shifting we do for periodic signals? It is a circular shifting. Okay, so x of n minus 4 mod 6. That means circular shift. Basically, this mod is used to write down the circular shift and circular folding cases and circular convolution cases. Okay. So, what is the 4 times circular shifted version of xn? What is the 4 times circular shifted version? See, what is the linear shifting? What is the 4 unit linear shifting? Okay, the samples will be shifted 4 to the right. But the problem is, we always define the signals in DFT or periodicity as 0 to n minus 1. 0 to n minus 1. We don't go outside this bracket. Okay, so these 4 samples, they cannot go outside the bracket. If it was linear shifting, this 2, 1, 0, 0 will come up here. But because they cannot go outside the bracket, they are circularly shifted, and the 2, 1, 0, 0 will appear in the beginning then. Okay, the 2, 1, 0, 0 will appear in the beginning. Okay, 2, 1, 0, 0, 4, 3. 2, 1, 0, 0, 4, 3, option number B. 2, 1, 0, 0, 4, 3. Okay, the 4, this 4 and 3 will go to the last. 2 1 0 0 and the same sequence comes to the beginning. 2 1 0 0 4 3. Option number B it is. Okay, 2 1 0 0 4 3. Circular shifting. Basically, circular shifting you must know how to do. Circular right shift and circular left shift. Okay. In a sense, circular right shift is circular clockwise shift and circular left shift is anti-clockwise shift. Correct. Did I say right? Sorry, this is anti-clockwise and left shift will be clockwise. I'm sorry. Okay, right shift will be anti-clockwise, left shift will be clockwise. Okay. Okay, so this is the answer, 210043. Done, dear? Chalo. Okay, fine. Yes. These are really important questions for EC paper especially. So this, the session, as I told you, 21 important questions and we are done with the 21st question. Okay, it took us nearly 2 hours. That is what was the expected time. Correct. Okay, guys. So just again a reminder that the fresh online live course for GATE 26 or GATE 27 just started 8th of February, and the fee for GATE 26 with 1 year validity is 99.99. For GATE 27 2-year validity is 28,999. And yes, if you can really travel to Hyderabad, or if you stay in Hyderabad, around Hyderabad, and want to study in a competitive atmosphere directly in front of the faculties, to take the advantage of the offline batch for GATE 26, the first offline batch starts 24th February. The fee is currently priced at 54,999. And if you belong to IIT, NITs, triple ITs or any state government universities, you get special benefits here. And also, if you are any of the previous home student, you will get the benefits here. Also, guys, if you want to study, of course, online, but at any time as per your convenience, at anywhere, you can also take the home online pre-recorded lectures. Okay, for GATE 26, you can have different modules of 3 months validity, 6 months validity, 9 months or 12 months validity. Okay, if you want to take the pre-recorded courses for GATE 27, you can have larger validity modules for 18 and 24 months validity as well. All these courses are available on the OHM Online Plus, and in fact, if you are preparing for AE also, okay, so there also you have the online pre-recorded lecture courses available. Okay, with the 3 months, 6 months and 9 months validity. The respective fees is clearly mentioned in front of you. All these online pre-recorded courses, whether AE or GATE, is all available on the OHM Online Plus app, okay, which you can get from the Play Store, or you can directly, if you want to land to the app, you can just scan the QR code which is available in front of you. All right, dear. Okay, so guys, for EC students, don't forget that 15th February 5:30 p.m. just after your exam, okay, the live EC paper discussion. The live EC paper discussion is going to happen 15th Feb 5:30 p.m. The live EC paper discussion will happen 15th of Feb 5:30 p.m. 15th Feb 5:30 p.m. So join us live on the YouTube channel on EC on the 15th of Feb 5:30 p.m. for live EC paper discussion. Okay, dear. Chalo, that's it. And yeah, of course, as always, I'll share you this PDF also. Okay, the today's PDF with a small password protection. So what is the password? The password is DFT. The last 2 questions were DFT based. The password for today's PDF will be DFT. I'll share you the password in my Telegram group. Okay, if you are not connected, I'll share you the link of the Telegram also, where you will be getting this PDF. But the PDFs always, as my rule and my ethics, are password protected. Because if you are watching the session, then only you are in the need of the PDF. And if you watch the session, you get the password. Here is the link of the Telegram. Okay, you're going to get the PDF here, the link of the Telegram. In case if you're not connected, I've shared. And the password will be DFT, everything in small, DFT. Okay, I'll share you the PDF today in the Telegram. Okay, dear, bye bye. Thank you. Stay safe and all the very best for the upcoming GATE 2025 Electronics and Communication